Hello everyone, today we are presenting our project titled 3D Printing Process of Mini Crane Model. My name is Lao Xian and I will be presenting together with my teammate Teh Lishan and Liu Qisheng. This presentation will cover the complete development of our project, starting from design to final product. We will discuss the introduction, 3D printing, process, objective, CAD design, printing, and finally our conclusion. Let's begin with the introduction. This project focuses on the application of 3D printing technology to transform a digital CAD design into a functional prototype. The process involves several key stages, including design creation, file preparation, printing, and final assembly. Our mini crane is designed with three main functional features: a stable base to ensure balance, a 360-degree rotating turret for flexibility, a functional hook mechanism for lifting loads. These features ensure that the model is both mechanically functional and structural based.
Thank you, Lau. My name is Dali Chen, and now I'm going to present about the flow of 3D printing. First of all, is the design creation. We create a 3D model using a CAD software, which is AutoCAD Inventor. After the design is created, we export the design as an STL file, which represent the geometry of the model. Thirdly is slicing process. The STL file is processed using slicing software, for example Ultimaker Cura, which can convert it into G-code, which contains instruction for the printers. After setting up the printers, the model is fabricated layer by layer using the FDM technology, which is fused deposition modeling technology, by melting and extruding the filament. After that is post-processing, which carry out to improve the surface quality and assemble the parts. Number seven is final product. The finished product is ready for testing, evaluation, or practical use. For this slide, I'm going to discuss about the main objective of this project. First is to develop practical skills in 3D modeling and design. Second is to understand the complete digital manufacturing workflow. Thirdly is to prepare and optimize models using slicing software and 3D printers. And lastly is to evaluate the functionality and performance of the final product. After presenting about the flow of 3D printing and objective of this project, now we are going to present about the first step, which is CAD design. The mini crane was designed using Autodesk Inventor Professional. Each component was modeled individually and then assembled into a complete system. For the special attention was given to accurate the dimension and proper fitting between the components. In our design included the base, turret, hook. These are the three main components of our design.
So now it's my turn. I am Liu. After the completing the CAD model, it is exported as an STL file and imported into the slicing software. The key parameters such as the layer height, the infill density, the print speed are carefully adjusted to achieve the optimal result. For example, the hook and the crane arm required to support the structure due to the overhang, and the base is printed with the higher infill to improve the strength and the stability. Okay, now it's about the 3D printer handling. The printer is used operate based on the field deposition modeling technology. The short form is HDM. The proper setup is critical to ensure the successful printing. That has four steps. And the first step is inspecting the printer condition. The second one is the leveling the print bed. And the third one is loading the filament material. And the last one is setting the correct nozzle and bed temperature. This four steps can help to minimize the error and ensure the consistent print quality. So now is about the printing process. During the printing stage, the model is constructed layer by layer according to the generated G-code. Support structures are added where necessary, especially for overhanging components. However, some common challenges may occur, such as the sinking, which affect the surface finish, wrapping caused by uneven cooling, and the last one is the proper parameter adjustment is essential to reduce this defect.
After printing, all components are assembled to form the complete mini crane. The design enables basic mechanical movement. The turret rotates smoothly, the crane arm can be adjusted vertically, the hook functions as a load holding mechanism. This demonstrates that the model is not only visually accurate but also functionally effective. The CAD workflow begins with creating a 2D sketch on a selected plane. This sketch is then converted into a 3D model using the extrusion process. Additional features such as holes and fillets are added to enhance functionality. All components are assembled using joints, and the final model is exported as an STL file for printing.
After we discuss about our design and the flow of 3D printing, now I'm going to talk about teamwork and safety. This project was successfully completed through our effective teamwork. Second, each member also contributed to different stages, for example, design, slicing, printing, and also the assembly. Besides that, safety was also a key consideration, especially when handling heated components of the printers. Proper precautions were taken to ensure a safe working environment too. A good communication among our team members helped to run the project smoothly and efficiently.
So in conclusion, this project demonstrates the integration of CAD design, additive manufacturing, and mechanical assembly. The final mini-crane model is structurally stable, mechanically functional, capable of lifting more load. This confirms that our design has successfully met the project objective.
Thank you guys for the attention. Our project successfully integrates CAD design and 3D printing to produce a functional mini crane model. We gain valuable experience in the full 3D printing workflow and improve our technical and teamwork skills. Overall, the model meets the project objective in both structure and function. Thank you.